In this video, we're going to look at the second half of the number puzzle from the 2022 AQA AS skeleton code. Alright, just as a quick recap, in the last video we were looking at the line if OK. Underneath this, we take two variables, solution and OK, and they are assigned values through a subroutine called LoadSolution. Let's head over there now to find out what these values will be. First thing you'll notice in the LoadSolution subroutine is the Boolean value true is being assigned to the variable OK. We then enter in some exception handling with a try and except. A quick scan of the except shows us that if the file the user entered previously is the wrong name, they'll be told it doesn't exist. This is explained in part 1, so I'll not go into that right now. In the first line of the try, the solution text file to the puzzle we entered is being opened and the values inside, which will be strings, are stored in file in. We then enter into a for loop where a variable called line takes the positions within the range of this loop, which starts at 1 and ends at the value grid size plus 1. Grid size is actually a global variable, which is assigned the value of 9 at the start of the code. Within this for loop, we are using the line variable to run through each line of our array solution. Now, you might be wondering, what is inside solution? Well, in the LoadPuzzle subroutine that we looked at during the start of the video, solution is assigned a value using the reset data structures subroutine. Now, if you can remember what reset data structures does from the previous video, it applies an array with blank placeholders to solution. Now, in this for loop, we go through each position of the array added. We go through each position of the array and add a value from the corresponding line from the text file puzzle1s.txt. Each time a value is added, a space is added just before it. We know this because it concatenates, which means joins together, the first line of the text file with the space variable. Space is a global variable which just has a blank space within it. We then have an if statement which checks to see if if the length of the first line we just added into solution is not equal to the grid size plus 1. This is a validation check or rule to ensure that we have enough numbers for the first line of the grid. If we find this isn't happening, the variable OK is set to false. A user-friendly error message is then shown and the text file is closed. The final line of the text file then returns the values solution and OK, which we know LoadPuzzle wants. And to summarize, this subroutine is a function which places a completed puzzle answer into the variable solution and returns this to the rest of the code so it can be used. Most likely it will be used to output the solution to the user. Let's now go back to the load subroutine. Alright, now we are back in LoadPuzzle and you can see the second if statement for if OK. This is actually not an appropriate way of using if statements because two conditions are the same. Should just be one condition with all instructions under that condition. So this code should just put the instructions under the second if statement should just take the instructions from the second if statement and place it inside the first. But anyways, enough criticism. I'm sure AQA did that on purpose, but if not, AQA, do get in touch. I know a few programmers that could help you next time. In the second if OK statement, we are taking a few Sorry, I'm not reading this right, am I? We are taking the arrays puzzle grid and answer, as well as the Boolean variable OK, and assigning some values to them using the subroutine TransferPuzzlelntoGrid. This subroutine requires the variables puzzle name, puzzle grid, puzzle, and answer. Let's take a look at it now. Alright, so first we assign the Boolean value true into OK. Then the integer value 0 is assigned to the line variable. And the cell info variable is given the first item inside the puzzle array. If you can remember from earlier, puzzle is an array with all the values from puzzle1.txt file. We then have a while loop which runs until there are no more values to enter into the cell info. Within this loop, we create several variables. First one being row, which is assigned the first value of cell info. What's interesting to note here is that the string values from the text file are being converted to integers. The same then happens with the column variable. Now a question you might have is, well, that's nice to know, but what's the point of these two lines? Well, so far when it comes to our puzzle, we've got all the data stored in an array. However, if you output that array, the user won't see it presented in a grid form, making it almost impossible to actually play the game. This subroutine, as its name suggests, is taking our puzzle's numbers and placing them into the appropriate cells within a grid. If you look at the text file puzzle and you look at the PDF file AQA produced, you'll see how the grid should look at the start of the game, and you should hopefully notice that each line in the puzzle1 text file contains only 3 numbers. The third number is the number to be entered into the grid, and the first and second numbers are the positions in the grid. The row variable takes the first number and the column variable takes the second number. We then have the digit variable, which takes position 3, which also just happens to be the third number in our list. You might notice this value isn't being converted to an integer. The reason is because there are no intentions to perform any mathematics on this number, so it can remain a string. On the next line, we are assigning the value inside digit to its appropriate position in our 2D array, or our grid. Then we add 1 to line, which means we look at the next line of our puzzle and go over the entire grid until there's nothing more to add. A subroutine is then called in order to assign a value to the answer variable. This subroutine is called ResetAnswer. Before we go there, based on previous exams, I would strongly recommend you pay very close attention to this subroutine and the reset data structure subroutine. They allow the program to not just create the grid, but fill in the contents. This has been a skill that Section C has asked students to do in the past in previous exams, so it could be in your best interest to understand how this works. Alright, let's take a look at the ResetAnswer subroutine now. This subroutine takes in the variable puzzle name and the array answer. It then assigns the value inside puzzle name to the first position within answer. Then zeros are placed in the second and third position. You should note that these zeros are strings. Our next 2 lines are a for loop which then works on the rest of the answer array. In here we are effectively ensuring that each remaining position in the array is empty. This result is then returned so it can be used by the TransferPuzzlelntoGrid subroutine. Let's go back there now. We've actually reached the end of this subroutine. The remaining lines I won't mention as they've been explained multiple times already, but we can just note that the values in puzzle grid, answer and OK variables are returned so they can be used by LoadPuzzle. Let's go to that subroutine now. The final if statement is if not OK, which again is a little bit questionable, as even the basic programmer should know this could easily be an else. AQA, just remember, I know some programmers in year 7 who could have helped out with this bit. This is all part of the validation rule, which will restart the process by using that line we've seen quite a few times now. Then finally, we return puzzle grid, puzzle answer and solution so they can be used by our favourite subroutine, NumberPuzzle. Let's go say hello for the first time in this video to NumberPuzzle now. Alright, up next we're looking at elif. Menu option is P. So you do know how to use elif and else after all. Interesting. Here we are taking the puzzle grid, puzzle, answer and solution arrays and assigning them values using the LoadPartSolved puzzle subroutine, which also makes use of these arrays. Let's go there now. Alright, first we are assigning values to puzzle grid, puzzle, answer and solution by making use of LoadPuzzle. We've already covered this subroutine, so go back to see what it does. Now, once we've got this all updated, we assign the first item in answer, which, if you remember, is the name of our puzzle, into the puzzle name variable. Then, we take the text file puzzle1p.txt and read it into file in. CellInfo then takes the first line of this text file. If you open the text file puzzle1p and look at the first line, it's the name of our puzzle, which happens to be puzzle 1. A validation rule is then used with an if statement to check if the first line is the correct puzzle name. If it's not, a user-friendly error message is shown. However, if it is, we use a while loop, and the first thing we do in this while loop is apply the value in CellInfo, which is currently the name of our puzzle, into the first line of answer. We run through the entire text file, placing each line into the next position of the answer array. This carries on until there are no lines left to add into CellInfo. The file is then no longer being read, and then we assign a value into puzzle grid. This is determined with the use of the TransferPuzzlelntoGrid subroutine. Let's go there now. The first thing we do here is make use of a for loop where line takes a position within the range, which starts at position 3 and ends at the value within index 2 of the answer array. If you can remember from the previous subroutine, answer has taken all values from the puzzle1p text file. Index 2 is our third position in the array. The number 4 is here. 4 plus 3 is 7. So our for loop will have the range from 3 to 7. This makes sense if you open the text file and see it for yourself. In our first line of the loop, we take the third index from our answer array, which remember is the fourth line in puzzle1p text file, and we place it into CellInfo. Now, the next 3 lines should look familiar to you. You'll know it takes the 3 values in this fourth line and uses it to place the third value of that line into the correct position in our grid. This goes on until all the values from the text file have been applied to our puzzle grid. We'll understand more about this later, but effectively what's happening here is the text file puzzle1p is meant to store a saved puzzle the user was working on. There's a subroutine later which allows the user to save their puzzle file. This subroutine allows the user to reopen the previous saved puzzle. This updated puzzle grid is now returned so it can be used. Let's go back to the LoadPartSolved puzzle subroutine. This subroutine is pretty much done. We now share the arrays listed at the bottom by returning them so they can be used by our NumberPuzzle subroutine. Up next, we're looking at what happens when the user enters K. You can see it just calls the keep puzzle subroutine. Let's go there now. Keep puzzle starts off by checking if we have a puzzle being played. If not, it shows an error message. But if we do have a puzzle being played, we then look to see if the item in answer position 2 is greater than. If it is, we can assign the name of the puzzle into puzzle name. Then we open the appropriate text file and write to it into the file out variable. In the next few lines, these are similar to what you've seen before, but instead of reading lines, we are writing them. The /n string just informs Python to start a new line in the text file. Once we reach the end of our range in the for loop, we exit and we are done. No values are returned here, making this subroutine a procedure. Let's now head back to to the NumberPuzzle subroutine to see what's next. Up next, we're going to look at what happens if the user enters C. C generates a score. So we first of all check to see if there is an active puzzle by checking the 0, position in puzzle grid. If this isn't X, this means there's no active puzzle. However, if there is an active puzzle, we check if there are available answers. Then, if there is, we assign some values to error count and solved. We do this by using the CheckSolution subroutine. Let's look at that one now. Over in CheckSolution, we first assign error count to 0, solved to false and correct to true. Error count is an integer, solved and correct are booleans. Incomplete is a variable which is then assigned the boolean value false. We are then using a nested for loop where the first for loop runs through the rows and the second runs through columns. The entry variable will be used to run through each cell so they can be checked against the solution. Then we have some if statements. If the entry variable is equal to space, it tells us that the cell is empty. If this is the case, we then set incomplete to true because there should not be any blank cells. The next if statement checks to see if there are mistakes, and it counts how many mistakes were made. If these statements are not met, correct remains true. Otherwise, if it is false, they are presented with how many errors are made. The rest of this code is pretty simple to follow. Let's now go back to the NumberPuzzle subroutine. Now we can see some simple selection which checks to see if the solution was solved. A message is presented to say the user was successful and finished is assigned true in order to end the game. Otherwise, it presents the user with their score so far. You can see this score is generated by using the calculate score function. We'll look at that subroutine in the next video. There's still a little more to go through, but we'll cover those in the next and hopefully final video.